to round out our lesson on neural networks, let's just end with some discussion of the different types of neural networks at a very high level. In future mini lessons, we'll talk about the details of the networks we're going to talk about today, but let's just get you familiarized with the three broad classes of neural networks, or at least three of the broad classes. So the first one is the type of neural network that we just used and worked through extensively. This is commonly called a multi-layer perceptron, because each of these independent nodes with edges going into them is one perceptron, and we have several of them, many layers. And so you could also call it a dense neural network. It's dense because each node has a connection to every node in the previous layer, so very dense. But we talked about this network in general. So this type of network is really good when you have, let's say, tabular data, or data that you would find in a CSV file, an Excel file, or other type of data like that, categorical data. But if you have images, images are a popular thing to predict on, then you might not want to use this type of neural network, a dense neural network, because you're going to have each pixel go in to each of these nodes, and that's pretty problematic because you're going to have a lot of input nodes. In addition, each node will correspond to a position in the input image, but that's making an unfair assumption about the input, that anything you're trying to classify is going to be in the exact same position in every image. That doesn't make for very good image classifiers. So instead, we tend to use convolutional neural networks for image classification. We'll have another tutorial series all about CNNs and image classification. But at a high level, convolutional neural networks start off with these things called convolutional layers, which learn to extract relevant features from images, and through a series of increasingly higher level abstractions, and eventually those features are fed into a dense neural network like we just learned about. So more on that, but the high level takeaway is that CNN's good for images. And finally, we have recurrent neural networks. This is really good for sequence data, like NLP text data is commonly used, or audio data, or word data like that, mainly text. So as you can see, we have a sequence of input. So this might be the word hello, this might be the word I, this might be the word love, and this might be the word MLPro, and that's fed as input into this neural network with a different architecture, which we'll explain again in detail in a future video and tutorial series all about NLP and text processing, where RNNs, recurrent neural networks, come into play. But there's a lot of edge weights. There's edge weights going from each input into these hidden cells, a bunch of things going on with these hidden cells, and weights going from the hidden cell to an output. So you can have an output at each time step, but oftentimes if you're doing like binary or multi-class classification, then you're only looking at the last output. But for other tasks where you want to output a sequence, you could also use recurrent networks. And there's many different categories and subtypes of recurrent neural networks, as there are for dense neural networks and as there are for convolutional neural networks. So even though there's many types of neural networks, they all basically follow the same gradient descent backpropagation process that we just learned about, just for the different architectures that are optimized for different domains. So you've learned the basics in this tutorial series. That's a big accomplishment. Now go out into the world and do some good with neural networks. Thanks for watching.